Hi all, I am Vijay Jithani. So in today's session, which is Az104 for implement and manage networking, this is purely on networking. So we will cover all whatever we have to do from exam point of view. Okay. So in previous session, we already covered some of the basics of the identity and the storage. Okay. So moving on, let's see what the agenda we have from exam perspective. So if you see from exam, I think we have weightage of 15 to 20%. And the topics which we have to cover is right from creating the virtual network and subnets, and IP addresses obviously will be assigned during those component creation, user different routes and network connectivity. So this is more on the virtual networks and how they look like. So from exam perspective, this is what we have as an agenda, but we will also cover some of the basics of the networking so you understand from scratch from where these networks are getting created. Okay. Similarly, how do we secure these networks? Obviously, we need to have some kind of firewalls or some kind of the access mechanism of how we do so from the web portal. So we have everything in place, right from network security groups and how do you access securely your machines. And similarly, there are something called service endpoints and private endpoints. So while we go through these topics, you will understand better. Okay. And finally, we will end up with the name resolution and load balancing. So again, from exam perspective, as I have been saying, there are three sections. One will be the multiple choice, one will be for yes or no kind of thing, from where you cannot go back and forth. Okay, so in that case, basically, apart from these, you have a case studies. Okay, so they will test you on each of these particular topics. In short, what I would say is right from creation of the network, how you secure those networks, and how you basically connect them across from your own environment to the Azure and vice versa. So they will test you on those particular basics. Also, whatever we are covering today is also will help you to clear network associates, that is AZ700 exam as well. Okay, so let's move ahead. I think from an agenda point of view, I have simplified the agenda in this form. What we will do is we will go through core networking fundamentals to cover what exactly the networking is all about. And then we will also see more of network connection topologies, how you should connect them to have a cost effectiveness as well as performance. And then we will look into security and traffic controls, connectivity and routing, load balancing and delivery. And finally, you see the hands-on labs. As we have been doing the hands-on labs after each of the topics, so similar way we will do in this session as well, because this gives you a confidence of whatever you have learned. We are moving further with that lab as well. Okay, so let's start. Okay, so let's first of all see what the networking is all about. So here, whatever you learn so far, you will have some kind of the network address. In short, that's we call the IP address. Okay, so these will be the bunch of addresses, and you can classify them in private as well as public. So something we use internal to an organization or even for test and dev, which you can use without any constraints, are the private IP addresses. And something which we need to buy from in our internet service providers is the public IPs. And as you already see from public IP perspective, they have to be globally unique, assigned by ISP and accessible from internet. Similarly, from private IP perspective, it is for us, similarly our a router at home, also non-directly accessible for internet, especially for the private IP address. Now, this has to have some kind of the, I would say, a rule which you should follow. So that is what is RFC 1918. It provides you. So I will just increase the font so that you should be able to. Okay. So If you see these IP addresses from class A, you have 10 dot range, class B you have 72.16 range, and class C you have a 192 range. Now for each of these network range you have a subnet mask, okay, /8/12/16. How we are actually calculating them is what we will look into now. Okay, so each one of them are being used for a specific purpose, or also I would say each one have the different capacity to handle the host. Host means us who are consuming those IP addresses. Network is something which is used for some kind of a service or to running that particular, say suppose if you are running a data center, so obviously you will have some kind of IP address used for the network devices and some kind of IP address you will use for yourself. Okay, so that is how the differentiation is between the network and the host. But how do we calculate them? And what is the recommendation is what we will look into. So if you have been working in your own home, right? So you will see it will obviously assign something of your router will assign something of 190 to 168 range. And we have seen that, right? So similarly, if you have been working in the uh, office environment, you will see /12 as well. Okay. And obviously, if you have been in an enterprise, 10 dot range is what you have seen. So that is what the typical uses is what you see here. And as I already said at the start, private IP address can be used by anyone. That means they live within your environment, so they can be reused. Okay. And the difference between the public is public are the IP addresses which are also address spaces, but they are allocated regional wise. That means your internet service provider buy them in bulk and then they provide you on some charge. Okay. But private IP addresses are free to use internally. Okay, so that is the reason you see even though you have an IP address at your home Wi-Fi, you are not being charged for that. You are only charged for whatever the internet service provider is charging you for broadband or whatever. Okay, so now let's understand how this works and how the these IP address and subnetting fundamental works. So first of all, what subnetting is? Subnetting is required because if you consider any of these addresses, if I assign these three, that means I cannot reuse them again because I am already using, or I would have, I would say, if I take 10 dot range, I would have lot of IP addresses which will be waste. I will not be use them. Uh, So I want what I want to do is I want to create small groups of these IP address based on the necessity. So that is where the subnetting fundamentals come into picture. That means the complete address what I have, that is 10.0.0.0. I want to divide into the small groups, or I would say a small address ranges technically, which can be reused for some purpose. Also, subnetting help us to improve security, reduce broadcast traffic, network performance, and network management. That comes because we are now, instead of using the complete addresses, we are now using the small group of addresses which will reduce the broadcast. Okay, now in simple sense, if you see subnetting, if I want to divide them, I can create a subnet A, subnet B, subnet C, subnet D, all from one particular addresses. But on top of this, I what I want is, okay, I will do this. What I want is I need to understand how this particular network concept works. Okay, so here is a simple notation. Say suppose I am going with the network address range of 192.168.1.0 and it has a subnet mask of 24. So what it means? It means that I have /24 for network and remaining 8 for the host. That means if I say 2 raised to 24 is the network addresses I have and 2 raised to 8 is what I have for my host. Now what is again, as I explained you, 192.160.1 is a network range. Okay, this is will remain constant. But what I want to look at is say this unique address which is assigned to host from where it came. So if you see the calculation, okay, so here are the calculations. If you go for 24, okay, that means I have last all 8 bits available to use. So 2 raised to 8 gives me 256. 256 minus 2, 254 is an available IP address range for 24 subnet. Okay. Similarly, if I want to use for slash 26, I would have the remaining 6 bits from 32, because 26 is used by the network. 6 bits stores 2 raised to 6 minus 2. Now, why this minus 2 is there? Because in the networking, while we divide the subnets, or while we divide the IP address space, what we have is first is reserved for our network address and last is reserved for broadcast. Okay, so that is the reason first address and last address are reserved and remaining you can use. So that is wherever you calculate your network addresses, you have to follow this particular formula. Okay, so I would pause here for a while so that you can understand, or I would say you'll see through this concept what the subnetting is all about. Okay, again I will just brief you for a while. This was the private IP ranges which we are free to use for all of us. Depending upon how we want to use, we can use it as per the network ranges, or I would say the host we require. If you require small, then go with the smaller subnet range. If you require more, go with the larger subnet range. But beyond this, what we are doing is we are doing the subnetting. That means any particular network we are taking and we are doing the uh, division of that network so that we can reuse it properly. So in simple sense, if someone gives me this address slash 24, 24 is the bits I'm using for the network and remaining 8 bits I'm using for the host. That is what is being shown here as a quick reference. How do we calculate it? Say the example shows slash 26. In this case, I'm only left with 6 host bits, 32 minus 26, and I'm calculating the usable host from that minus 2. Network address first address, and the broadcast is the last address. Remaining we can use for our host means our servers can use that. Okay, so remember that for network management, network monitoring, and all the network related activities, we are reserving the network address as well as the broadcast address so that they can communicate internally. So this is the basics of networking. So now let's move ahead. Also, as I was saying you, say for 24, this is the small table I have put across. Like you can how you calculate your total host and how the address will look like. The first three octets will remain same. That is, if I'm going with 192.168.1, so access will that will remain constant. What is actually changing is 1 to 254 is the last octet. Similarly, 1 to 162, because here I have only 62 hosts. Okay, and example wise, the way I was saying you, I want to use or want to divide this in small segments or small IP address pools I can reuse. So the example network per se, I have a different departments: sales, HR, finance, and IT. Each of them requires some IP addresses. So what I will do is I have a constraint of slash 24. If I use it, they will have all different policy. They all have different policy. If I use only one addresses, it will be difficult to have apply policies to all of them at once through network. Better to segregate them, not only from security per se, but also from the management per se. It becomes very easy if they are being assigned in a specific bucket or pool, so that I know that which specific IP address I have to assign if someone is coming from sales or if someone coming from finance. Okay. So while these are very basics, but for someone who is starting, that is the reason I'm giving you these fundamentals of networking before I jump in directly into Azure. Okay. Again, I will pause here for a while before we move further. So this was about the IP addressing and the subnetting. But how do we connect together? So for that we have a topology. Now the way it have started is from the legacy LAN, they used to use the kind of one particular cable, and everyone is sharing that cable or patching to that cable to access. That is what we call the bus technology. Okay, so there's a single cable, and we have the computers using that. Okay, but as the networking has evolved, we have been using a kind of hub versus spoke networks. That is where we call the star. So if you heard about hub and spoke, this is like central who is giving us a service and we are consuming those service. So we'll be in form of star. A simple example is your own router or broadband at your home. The connection is coming from your ISP, so they are the hub. You are consuming, or whichever computers are consuming that service through router, they are basically the consumer. So we are connected in a star. Okay. Now there are other networks like telecom networks which uses ring. Even though we know that there for each of them, I think uh, there is an advantage as well as a disadvantage. In case of star, everyone is depend on this consumer, but I think that is how it should work. ISPs has to provide you service and you have to consume that, so we cannot help much on this. Similarly, is for ring, if something breaks, I think we used to say that now this is we don't have any particular redundancy, but nowadays we have moved across this. We have, instead of having one ring, we normally create the two rings, so that if any one of this ring breaks, we uses the reverse way of connecting together. So now the telecom networks, even the networking has evolved. Also the also one thing is like why you use a ring networks today as well is because if you are moving from point to point or geography to geography, I can't have one single cable connecting to each of the geographies from the central, where central tower. It will be very costly to lay down those cables, and also it will be very difficult to manage if you have millions or billions of people using those services. Or even for even own towers as a data centers, you can't go from central to all the data centers or connecting all the respective zones together. It's very difficult. So ring is still very useful. All your ISPs, right, from internet service providers and telecom networks, they still use ring in some shape or form, because they know that being in a particular geography, they don't have any other way to do the cost effective connection. That means what I'm trying to say here is, suppose if you are in particular area, suppose section, right? You are particular state and these are respective cities. You can consider this way for an example. So each of those cities will have their own central tower, and then you consume those towers with the help of the star or some other topology. So in short, what I'm trying to say here is a ring is still a useful topology where you want to do the cost saving, as well as today we have moved beyond the single point of failure. That means instead of providing the single, we have the again reverse way of connecting. So we have redundancy in place if any cable breaks out. Okay. Now other thing which where you cannot have this disconnection is mesh. That means here it will be very costly for me to connect point to point, but that is how it should be if I am using the what service like data centers or provide. I am the ISP, so I cannot have single point of failure, that is internet is down from one particular cable or one particular geographical area. So I need to have the redundancy in place so that we give 24 by 7 services. Okay, so in this case mesh is very important, and the example you are clearly seeing data centers and WAN tree. Obviously, you being the head, you have seen the college networks or even the hospitals or even the other where you are actually having the campus networks where the head office controls all the small branch office, or in your own office as well, the main setup is at your head office and the other office just consume with the help of the hierarchy. Okay, so in that case tree will be very helpful. Hybrid today, as I said, we can't just rely on one particular network topology. We have to go through, like say suppose in our home we are using, as I said, consumer, the ISP is providing us an internet service through, and then we consume for our, through router we consume the internet. But whether the ISP is using that or using a data center, no, they are actually maybe using some kind of ring or some kind of the tree, so that those both are connected in form of something of this kind or something of this kind. So we are actually combining the topologies together to have the best of the performance, or the best also have the cost effective management of connecting together. Okay, so again I will pause here for a while before we move further. Okay, so all basics are covered as of now. We covered some of the fundamentals of networking. That is how the IP addresses come from, whether they are public versus private, and how you subnet them so that you divide them in respective pools and can be used for specific departments, or the organizations have this kind of the bifurcations. So most of you might be aware of this, but I think for someone who's starting fresh, that is the reason I have given this particular fundamental for you. Now let's start with what we have from exam perspective. Okay, so from exam perspective, you have to learn like what the Azure virtual net is. So whatever I've been saying you, as you are not the ISP, you will be mainly dealing with address space of, you are dealing with private IP address space only. Okay. Similarly, while you do the subnetting on top of that /24 /16 or /8, you are actually doing the subnetting on top of that. And from network security group perspective, I think we will also learn how we are actually controlling the traffic coming in versus traffic going out, which are the ports available for access. Like say I'm using the virtual machine, so I have to RDP to that virtual machine. So 3389 is a port, so I should allow that port before it can be accessed. So network security group should know that for that particular network, otherwise I won't be able to connect to my virtual machine. A route table. Now this is more of a, I'm just giving you from the top. So DNS, the way it resolves your name to IP, routes give it a direction. That means I want you, the way your ISPs give you only one IP address through which they DNS server through which you actually resolve and go to the internet, is what you normally go through, right? So in route table, basically what I tell you is all the traffic should go through my firewall or some kind of appliance which controls my or monitors my traffic before going out or before coming in. That is where the route tables are very important. So there are different route tables, right, from system, user defined and all those things, so that you will learn slowly while you go through this networking. Okay. Virtual machines, firewall, and VPN gateway are the devices. I think we will learn through them while we actually go through the labs as well. Okay. Now, in simple sense, the way we have seen our address space 10.0.0 is 16 is an address space. Again, this is not the RFC 1918. We have been using it a different. We only want a two octets of last 88 bits, that means 2 raised to 16 addresses. Okay, that is what I want. So in that case, how do I bifurcate? Like what I'm using is, out of 16 I'm only using 24 for web, 24 for app, 24 for database. But I still have the other. That means from right from 1 till 254. Okay, I will use it for the networks, and the remaining zeros, all 255 at the last octet you are seeing, I will use for all the VMs and app servers and SQL servers. So you have to correlate whatever we have learned before, or just even if you are getting stuck with just search around for the subnetting fundamentals, you will get these. Okay, so here we are creating a respective pools which we call the subnets for the respective applications. So in short, this is what you're doing for the virtual network. Okay. Now, most of the time, what you will see is they are connected in hub and spoke, as I said, because what we want to do here is, now this is sample hub and spoke and architecture. What we want is something to be controlled, or some services which are shared across all the networks, they should remain in hub, because they control what is coming in, what is going out. If I want to have the VPN connection, that means I'm connecting securely over internet, so I should have that. If I want to connect to any machine, the best in the service, there will be other shared services like the DNS server, your identity management services. So those all services should remain in hub, because they are the central to your actual infrastructure. And what I want to run in the production is for the respective application. Say suppose web, app, and DB. We have the different subnets for that. Similarly is for your development, similarly is for testing. I have the three environments. All three environments will use the basic shared services for the hub. So this is in short how you look at the how the networking is being done in your organization. Now, before we move to security and traffic controls, I want to show you the lab on this particular virtual net. Okay, so let's go through the lab 4, which is a part of your hands-on labs. So again, if you go to if you just search around AZ104 Microsoft Azure Administrator, you will be able to go to the GitHub site, and from the GitHub site, just click on the Microsoft Learning dot for the Administrator Labs and come to the lab 4. This is the start of your virtual networking lab, and let's see what we have to do so far in this particular lab. Okay, as we have covered some basics on the networking, let's create a virtual network at first place. Okay, so if you see the lab scenario, it is of 50 minutes. From the diagram, I will explain you. It will be better to understand than reading these two lab scenarios. Basically, you want to create the two virtual nets. One is core services, another manufacturing. And in this manufacturing, basically, you have the task assigned to that. First task is creating your the network, which is core services VNet. In that you have two subnets. One is shared service subnet and database subnet. Similarly, is for manufacturing, you this is the network range, and then you have these two subnets. Okay, so from the DNS per se contest.com, and this from the private. For this you have this DNS at contest.com. For private dot is used for your the other VNet. Okay, so this is what basically you have to do for all the three tasks which they have assigned to us. In short, create a virtual network. Okay, this is using the template. That means we will use an ARM template. Create and configure communication between application and network security group. This application security network security groups are more of a firewall. This is to do with how the VMs work internally. How because application security group is grouping of the similar kind of VMs, and network security group is, as I said, the firewall uh, that will control incoming and outgoing traffic. So let's start with the basics of how to create the. So I think they have given first. I will just walk you through this so that you understand what we have to do. They have given you step-by-step instructions to go to the portal, search for virtual networks and a respective naming convention. So what I will do is parallelly, I will just create these VNets. Only thing is I will just replace this with the new addresses, because what I have is I have already been using many of the addresses. So I will give it something different. Instead of 20, I will go with 40, 50. So that is what I will use it in my case, but I think rest all will remain same. And then you have to create the different subnets for the service as well as database. Okay, once this is complete, what I will do is I will download this as an ARM template, and then we will create another virtual network which is manufacturing virtual network along with the subnets. And then they have given us the another task of creating an application security group and network security group. So we will do this uh, creation of these groups, and I will show you how these particular are working together. And finally, obviously, we will see how the traffics are flowing. This is step by step. I think you need not worry about the instructions. The instructions are very clear, and this is very much workable. So I will show you the public DNS. So this is basically to just to give you an how actually it works internally while you create the DNS zone, and also for the private DNS zone. And at end they give you to clean up, but I would say don't clean up, try to use this complete setup for your next lab as well. I will show you how basically you without deleting this also you can reuse most of the networking stuff, or I would say in a single resource group you can use and then delete, so that you know what kind of the lab you have done overall for the networking per se. So now let's get started. So first thing is I have to create core services VNet. Let me move on to the so Azure portal. So this is my Azure portal. I will click on virtual network. Okay, before this, I think you remember we used to create a resource group and with give some tag. So let me create a resource group. What? Okay, so let's search for resource group. Okay, so first thing I want to create is now this is already AZ10 lab is there. So let me create something for networking. So what I will give name is AZ104 NW labs. Okay, so this is what the resource group I want, and I want to make sure it has tag because I have kept the policy which will not allow me to move further if I don't give this tag value. So this is how we have started, right? So I'm just giving it some department and the name is test dev, and then obviously I'm reviewing and creating this resource group. Okay. Now what will happen is through these policies is I just give this particular tag to just resource group and it will inherit from the policy to all the resources which is creating within this resource group. So this is how the Azure policies are working. Okay. So let's go to this resource group, and now, okay, it's created. So what I will do is now move back to the virtual network. Let us now have network, and I have to create new, and I have to select our network labs. Okay. So let me give, as I said, the virtual network name. We have core services VNet. Okay. Now this is the name. At this point of time, I would say leave this, go with the default address space, go with 40. Yeah, okay. So I think what we were doing is the octet selection. So as it is 16, so that is the reason I was using this octet for 40. So pardon me for here. So because this is what I have to use. I have used 20 and 30, but 10.40, 0.0. Now this is all 00 will use it for host, and by default you will have this subnet, but I want to add the another subnets as well, right? So what I will do is starting from here, that means 40 0.0, I want to use /24. So what I will use already one is being used as a default. Other thing I want to configure here is one for shared services, one for database, right? So let me do that. So click on subnet. So default here I have to give the name. Okay. So that is shared services subnet. Okay. So starting address here, I can go with, as you already see, the default is 40.0.0. You can go with 1.0, or you can go with whatever is given in your lab. Okay. So if you see in your lab, you have given 10 or 20, but we should not waste the addresses. They should be very continuous. So what I'm doing is, instead of using 10 and 20, I'm just going through 10.40.0.0. This is my complete address space, which is shown here. I know already there is a default subnet which is 10.40.0 to dot 255. So I'm using, I will show you again. If you see, I'm already having the default subnet, which is going from 0 to 255 at the last octet. So what I want to use it now, move ahead from here. That means 1.0/24 to use the another. Okay. So this is how I want to create an another address. Okay. At this point of time, keep everything default. Don't change anything here. Okay. So just give it the name shared services subnet. Okay. Add this. Now this is shared service. Now one other thing is, I want to create the database, right? Database subnet. So let me create that as well. So here again, this address will remain same. I think as it is continuous, I think it is giving us directly /24 to be used the next available address. Okay. So even though sometime the way I misspell the octet, it will give you that this is already being occupied. So make sure you understand and see these warnings and accordingly move ahead. Okay, so I'm just clicking add that. So I have three particular, oh, I want to change the name of this to the database. So what I will do is, let me database subnet, save. Okay, so now we have one default, another shared service and database subnet. So that I have created. What they want us is create this. That's, so I'm just showing you. Okay, we did this, we did for database, we review, go to reday, take a minute for setting blitz, and okay, so let us review and create this before we move ahead. Okay, validation is passed. Let me create this. So at this point of time, we are having our resource VNet created for having three subnets. One is default created automatically, and another shared service subnet and database subnet is what we have created. Okay, now what they want is for us to automate this another. So what you will do is, from your export, come to the VNet, export template. Okay, let it load first, then you will be able to download this particular ARM template, so that next VNet whatever you're creating, that is for manufacturing, you can create it through the ARM template. Okay, so just download this. You can download both of them, template and parameters, but I think as this is just the single parameter it's showing, I think better just you do with the template itself and just give a name. Okay, so in parameters, if you see whatever we have, you have to see whatever values you have given. Similarly, the network ranges, this is the address space which we had. Then out of that, this was the default subnet, then we did for shared service subnet, and then we go for the database subnet. So basically what they are trying to show you is, now how do we automate that. So what I will do is, now another part of the lab is to create this using the ARM template. So let me first download, have this template.json available to me and do the changes for manufacturing vnet into that. Okay, so all the naming conventions and the addresses I have to have, that means address space I have to change. Now here it is from 20 it is moving to 30, but in my case I've already taken 40, so other will be 50. Okay, so I have to remember that and accordingly deploy this template. So let me first of all search the custom template deployment. Just search around custom template. Okay, so you will get with this screen, which is, and you can say in custom template deployment, build your own template and editor. Okay, now this is what the default you will get, but I think you have already downloaded the whatever you had. So I would also paste what I had before. So let me paste the complete template, and also I will show you the changes which have to be done. So this is exactly the same template which I have shown you in the download. The changes which I have done is, instead of core service VNet, I have now put manufacturing VNet. Okay. Now in this particular, wherever you see the specific network, now remember we already have this range. So I have to change this range to 50. Similarly, for default also, I want to make sure I change the respective address space. So I'm doing it for default as well as the sensor subnet 1, now sensor subnet 2. Okay, so these are the few things I think from networking you have to. Now this I'm deploying through ARM template. So you are seeing, first of all, I'm just having the naming convention, using the virtual network creation from this, then a respective subnet creation from this, and then finally it will go and have the deployment for these resources. So I'm just checking if I have not forgot anything, any changes. I'm just doing in front of you. So you have to do this address changes. Okay. So I believe I have a proper naming convention. First of all, you have to see wherever you have the core services, just replace it manufacturing VNet. So wherever it was having that naming convention, you just have to rename them to manufacturing, because that is what we have to create now. What we are creating is this, from this core services we have to have the manufacturing VNet now. Okay, this is a manufacturing VNet through deploy custom template. So let me deploy this. Let me see if I have the right addresses. 50. This is complete address space. I'm doing the subnetting on top of this to 24, 24, 24, 24. That's correct. Okay. So let me create this or deploy this template. So if there are any problems, it will not allow you to save. Make sure you use the same resource group so that you're able to see, and it is pulling out the name manufacturing VNet. Okay, so let's click on next. What we have is the reviewing of this particular, whether whatever changes we have done is correct. It will check for all conflicts, right? Then it will go for creation. Remember, this is deploying to our network labs. So once this is over, I think you should be able to see the network manufacturing VNet within this particular. Okay, I think it has done that. So let us check. So now this we created manually and this we created through the ARM template. Now let us move ahead with the next section of the lab. So this is what we have done. What next we have to do is we have to create and configure the application security group and the network security group. So let us do that. So let us have the naming convention the way they want, ASG web. Okay. If I do this, create, just create, this is what is. And let's do one by one. So let us first create application security group. Now, as we have already seen in our theory, application security group will basically the merge or I would say group the relevant machines so that the rules can be applied through the network security group to that group rather than going and targeting one specific machine. Okay, so let me select the way I have not this, sorry. I have the name from here, ASG web. Okay, so ASG web is what the name we have to give. And here, don't worry about the tags, it will be taken care automatically because what we are doing here is from a resource group, it will be inheriting. So let us see our next task. Network security, application security groups getting created. After that, we have the network security group and my energy secure is what it is. Okay, you did the application security group. Now let us create the network security group. So this is the, and where you will find is within your resource group. Just go to that resource group and see whether that is created. Okay. Now let us create one more for network security group. So this is what the name I have to give. Again, nothing to worry about anything here. Just go and create the network security group first. It is straightforward. Just create the way you created resource group. Similarly, you just create a network security group and occur the application security group. And we will follow the instructions like what. First of all, after you create that energy, go to set associate these subnets because if we want to have this, then we have to associate that. And then on energy itself, you have to have inbound security rules. So we will add this source we will apply for web. Let's do one by one. First, let us associate the subnets. Okay, it is done. So let me go to that resource group and then my energy secure. Okay, so here, if you see subnets, associate these subnets. Now I want to have the subnet from the network labs, right? This is one network. Okay, subnet, I think it is giving us which to associate. At this point of time, we don't have, we just have to associate this core services VNet and shared service subnet within that. So we will go according to that. Okay, this was the association. Now we want to apply the inbound security rules, right? So again, we will go to the settings and then see in the inbound security rules. Okay. So these are the defaults. So you have to add new one. Source, we have to say application security group. It will give you this available security group. So we have one within lab. So we have to take NW. Okay. And then source, source was any, and then we move to the, let me, any asterisk any, and then we have a custom service destination 80 and 43 TCP allow priority 100, and this is the name we have to give, allow ASG. Okay, ATN 443. So let me, any custom, we have 80 comma 443 TCP, name I have to give allow ASG. Okay, so just see what we have: application security group, web, source port range any, custom port range, TCP, and then priority 100, allowed ASC. Okay, so I'm just clicking add to this now inbound security. Okay, so it is now added. Now remember what we have done. Instead of allowing any particular VNet or a specific virtual machine, we have now just allowed an application security group. Application security group can consist anything within. Like tomorrow, if instead of two VMs, I am having three VMs, need not worry about or need not do again the. So that is what it is very helpful. Okay. Now this was for inbound. Let us do for outbound security rules. Again, it is for any service tag, internet custom destination, any protocol, any action deny, priority 4096. So what I will do is I will just copy this and remember the other. So let's see. I want to block the, want to block the internet basically. Just see whether we have done everything. So internet custom destination port asterisk, I have to mark it asterisk, any deny 4096. This is what I'm doing. Okay. So instead of just 80, I want to put asterisk. Okay, that means everything going to an internet will be blocked for this particular outbound on this particular network. Okay, so our outbound section is also done. Now let us configure a public DNS and the, basically here, unless and until you own the domain, you cannot, you should not do the DNS zone, but for sake of showing you something, they have given you this particular exercise just to configure a DNS zone. So what I will do is instead of contest.com, let us put our own Az104 networklabs.com as a DNS name and then create a public DNS zone from it. Okay. So let us do that. And within that, we also have to one dummy record of one particular IP address showing that we are able to resolve that. Okay. So let me do that. So DNS. Zones, the way I have did it for AZ Lab. So let me pull down something else. Resource group. Okay, so this is the, so what I want to have is, let me put the name here. So AZ104 networklabs.com. Okay, this is the zone I want to create. Okay, so basically here it will just go and create a zone for me, which is AZ. Oh, okay, I have to also give it .com. Oh yeah, I've given .com. Okay, AZ104 networklabs.com. That's correct. Okay, so this gives us a dummy DNS zone because I don't own at this point of time any of these. But this is the way to show you that if you create the DNS zone, then what kind of the management options you get. Now, what I have to want to add is this is the startup authority giving me this host servers of this. The other thing I want to add here is I'm just want to give some address. Okay, so say suppose www dot that this should resolve to this particular IP address. So you can select any, say I want to from my shared 10.40 dot say 1. Okay, so I want to say that this particular www.az104 network lab should resolve to this particular IP address, and www is the record. If I give www.ns the az104 networklabs.com, I should be able to resolve to this IP address, and you have to click add to that. So this is the record set which we just created. So if you see, what they are also telling us is a record, alias no, TTL1, and they are giving some IP address. You can use this or you can use within whatever, and select add to verify. Or so how do we verify? So what we can do here is let's run this NS lookup within our. First of all, I want to make sure I have the server name, that is the name server. So for that, what I want to do is I want to take any one of these name servers, say this one. I'm just copying it. Let it I am just using the shell, cloud shell from here. Okay, so now if you directly go and say az104 nwlabs.com. Okay, so should work, I think. Let me check. Oh, I am misspelled. That is, I think. Okay, so at this point of time, it clearly saying I am not the authority because it does not have the this domain uh, able to resolve this domain. It should be able to resolve to my IP address. So for that, I want to give it a name server. That is where I have copied this name server so that it gives me an IP address which I have configured for it. So that if someone gives me www.azlabs.com, it should resolve to IP address which we just configured, right? So 40.0.1 is what we configured here, right? So it is now resolving to that because it the previously, if you just give the without this name server, It gives you some server and address because we don't, to be frank, we are not owning this particular domain. So that is the reason it's giving us the server and IP address, and could not find anything for this domain is because it's not registered. But for us to resolve, just to check that DNS zone is working fine, we just given some dummy, I can say, the IP address just to say it resolves to our internal DNS server. So that is where I'm getting 10.40.1. Okay. So with this, I think we created uh, the public DNS zone. So private DNS zone is also the same thing. To be frank, for us, uh, we won't be able to check them. You just go through. I'm not creating this, but I think straightforward. You similar to where we have created. You just give the in private DNS zone. Just go with the some name similar to this, and then link in DNS bait virtual network link. I just have the link created for that particular VNet and give some dummy record set the way we did for. But what is the difference is public is will resolve your complete addresses over the internet. Private is something which is internal, so obviously this will only work for your manufacturing VNet, and outside of virtual it will not resolve to this sensor VM. Okay, so that is the difference. So in interest of time, I'm just moving to another topic, but I think hope you have understood this particular lab and you should be able to follow from here. So let's move to our uh, ahead with our next topic. So virtual VNet and hub and spoke is what we did. So what I want is now let's go through each one of them. So while we created network security group as well and application security group, application uh, just go through. I think I have explained you, but I think go through this diagram as well. As I said, this is more of a firewall. It controls your inbound as well as an outbound traffic. What should be allowed, what should be denied is what you will go through in network security group. Okay. How it works, I think, irrespective of from where you are coming, there has to be some filtration of traffic, and you may be running some of the virtual machines which are using these IP addresses or subnets. So the traffic allowed and denied is based on the whether you are using specific, whether you have allowed that particular port range, network range, or machine itself is where the network security group will work. Similarly, for application security group, remember we applied the energy on using an application security group. That was a reason was basically we want to group the similar kind of VMs and then apply the security group rather than applying inbound and outbound to every VM, every machine or every component we have in that net from that per se. Okay. That means what I want is whoever tomorrow I'm adding the new VM, I should not be bothered about that. Okay, I just have to add that particular VM in application security group at the backend, and the energy will still remain same. That means the ports which I have allowed will remain the same. Just I have to add that respective server or VM in application security group. So again, let's go through what we have. Application security group is a logical grouping of virtual machines and network interface. What we are trying to do here is completely visible in form of the graphic. Okay, you group the VMs and have the energy applied on those particular application groups. That is how we are controlling our traffic. It is easy to manage, and moreover, as we are able to group the VMs in future, if you have even 100 VMs, you just have to add those VMs in application security group along with the network. That's done. Which net, even if you have a multiple network, if you only have one particular NIC, then no need to worry about that. Okay. So remember, this is how you control the traffic. First was NSG, which actually allow and deny. Another was application security group is grouping the VMs in form of the respective, whether there is an app, whether that is a DB. Okay. Now another is Azure Firewall. Now, what is the difference? Difference is whatever you have seen in NSG, firewall also does same, plus because it is an hardware and appliance, it has a more capability to actually do the lot of filtering. Okay, so that is what, if you see in the description, it is managed stateful firewall asset that provides centralized, scalable, and highly available network security. So what I want from here is, first of all, it should be able as a single able to handle the traffic. Okay, NSGs were at the VNet level or subnet level, but I want to handle the complete incoming traffic from the other networks like on-premise network. Or so the way I said in shown you in hub and spoke, the firewall, the DNS remain in the shared services net or hubnet because of that, because it is the whole and soul of passing your traffic through. Okay, so if you see, it is for all filtering. Also on top of that, it will be able to do the threat protection. That means if some traffic is not legitimate, it will block those traffic. Similarly, from visibility and monitoring as well, if you want to have a look into health probes for respective network or subnets, you can do that. And you can provide the logs, providing the basic filtering around FQD and IP ports, even protocols being used. So this is what it is being shown in this particular graphics. Okay. Now the other topic, moving ahead, firewall is service endpoint and why it is used. See, what happens is you may have some of the services which are running platform as a service. For us to connect to that particular service from the infrastructure as a service, that means I have one particular VM or some network interface or even some kind of devices which have the some network configurations. What I want to use is, I want to use this service securely. So what I can do is I can have this service endpoint. What I want from this is basically within our network itself, I have to have this endpoint connected over Microsoft network and connect to this particular respective services which allow the service points. The key points, as you already see, whether you are connecting to respective service, traffic does not go over public internet. That means I am connecting this VM is connecting over Microsoft, so I'm not going over public internet. But yes, as I'm connecting to service endpoint, I am connecting this particular service over Microsoft publicly available PaaS services. So these are the publicly available PaaS services. You can still apply the NSG rules and UDRs. So you can consider the example as this way. I need some of the database to be accessed, but I want to connect it securely only for that particular network. Okay, so in that case, in virtual network, I have to select the service endpoint which will be connecting to this particular available services. Okay, now as I already said, you are connecting securely. That means instead of going over the public internet, you are using the Microsoft backbone itself with the help of service endpoint enable. Okay, remember this is what you will see while you actually configure this particular VM or that particular network. But what if I want to go over the everything on the private network? In this case, I have a this this traffic does not go over the public net. That means not even the services from Microsoft. In the private link and private endpoint, what I will do is I will actually go to the virtual machine, have the specific subnet, assign a subnet IP to this, also have the private link configured. That means what I'm doing is this flow is for each and every step I'm having or I'm going only through a private network. Also, what I will do is I will assign a equivalent IP so that I can make sure I connect to this services which are available publicly only through private link. Okay, that is the reason private link and private endpoint. Endpoint is my machine. Private link is something which will connect to these public services available over public network. Okay. So if you see, in short, let me services VM. So say suppose, let me go through virtual network as well. So that will give me the networking of the core services VM. Okay, so let me pull down something from here. Okay, so if you go to this, now what I want is, as I said, I need a service endpoint. So I actually want to see which network this particular VM is, go to the respective subnet and add a service endpoint. This will allow me a virtual network and allow me to select a respective, say suppose this is in shared service subnet is first I will select. Then it will allow me which service I want. So suppose I want a Microsoft SQL. I just have to click save. A service endpoint is ready for me over that subnet. But what else I will need is, again I have to go to this Microsoft SQL or a respective, say suppose rather than SQL, go say storage account. Storage account in networking, I have to add this subnet before I can actually connect to this particular service endpoint. So this is what I want to show you. The other thing which I want to show you is a private link, the private endpoint. So in private endpoint also at this point of time I don't have any because I have to add this from the networking. So in interest of time, as this is not in labs, I won't be able to show you because this we already have lot to cover. But in short, the difference will be want to have create a separate IP and have the networking configured with the help of in that particular machine. That means in respective subnet, have the IP, then have the private link which connects to this storage account. Okay, so it will give you now if you see the private endpoints and link, you can create. So just to give you a heads up, how you can create, just select whatever name, network interface and region, and in resources you should be able to, let me go it fast. Okay, so I want for what, so you have to select accordingly the path services, say storage accounts, which resource, so you have to select that resource. So remember, this is how you will navigate. I have just shown you the private endpoint and link. As these are very advanced topics, I am not touching more on this because every particular networking component needs some time to be, and in interest of time for this particular lab, I think I am just giving you the info on private link and endpoint. Okay. So again, just pausing for a while so that you can go through this private link and endpoint before we move further. Now, as you already have understood that we have a different NSGs and the application security group or even the networking firewall in place, how do I connect to my VMs in a very secure way? The best part is use the Azure Bastion as a service. The only thing you have to prepare yourself is wherever you are, make sure you create a separate subnet for that near to your VM so that I would say the VM says one subnet and the same network you create a Bastion subnet, give access to this bastion from an outside world, and have this subnet to subnet will they will be allowed to talk internally to the VNet unless you block that particular traffic. So this is everything is allowed from Bastion to this, but for an outside world, you should know this Bastion IP address before to connect to this. So if you see this how it works, let me increase font if possible. Yeah. So from user per se, what I want is I need some secure way to connect to my VMs, and no outside world should be my VMs should not be available on public IPs. Also, it is not feasible to give the public IPs to each VMs. So better I have a Bastion which just have one single IP publicly that is only available only over particular ports. So I'm only having this exposed. Then internal subnet will talk to the internal subnets of that particular VNet. So this is how the Azure Bastion is all about. Rather than going directly IP address, I'm just giving this particular uh, through a VM Bastion to the VM access. Okay. Topic for the our second lab. So this is what we have to do. We have already created the core service VNet. We have already created the manufacturing VNet. Now, how do we pair them? Is what we will see in the VNet pairing. Now, today what happens is VNet to VNet communication will not happen directly. That means whatever machines, if they want to talk, they want to have some kind of one-to-one routing enabled for them to talk to each other. So instead of going for one-to-one, VNet, what VNet pairing does is it gives you a way to connect to all machines with the help of peering. That means I have a shared services subnet, I have a sensor VMs, I have the different VMs in the manufacturing. What I want to do is I just know these are the VNets and I just want to go peering and do it for ourselves. Okay, so let us do this particular lab and you will understand this DNS which I have already shown you. So will not explain much on that, but I think let's finish up the peering part. Okay, as per our lab. Now in this lab, which is for inter-site connectivity, we already have uh, the VNets. But what we want to do here is, as I said, don't delete for because otherwise what you will have to do is you have to again create this particular VNets and so before creating this particular like VNets and have the pairing for them, you should have this ready. Okay, so at this point of time, what I did is um, I have from my previous section core service VNet and manufacturing available. I will just show you the how we do the pairing. Okay, so before I think doing that, I think they are asking you to create a virtual machine. Go through step by step and create these virtual machines. So in interest of time, I will not be creating this virtual machine because this is a straightforward, but at least we'll show you how you create these particular what VNet pairing. Okay, and then with the help of this network watcher, you can actually have those tested. Okay, so what I will do is I will just show you the VNet pairing. So for that, let me come down directly. This is VM, right? So yes, this is VM. So at this point of time, I should directly come to the fourth task. Yeah. So in take any particular VNet. So suppose in my lab, which is I should be able to make out for this. And in this, basically, if you come to the pairing, I don't have any pairing at this point of time, but I have to do the pairing. So say suppose there are two things here. One is your remote. and another is local. So at this point of time, remote is the manufacturing, right? So suppose I'm sitting on the core. So that is what it says in the lab. You give a name manufacturing to for remote. Okay. So let me give that name, and from the virtual network, I have to select what is the virtual network. So this is manufacturing VNet. Sorry, it has to be from this link. I have to connect to this. Just I think what is the problem? Yeah, I think I was selecting some apart different. That is the reason it was giving me the error. So for remote, I think I'm sitting at core. The virtual network will be the manufacturing. Similarly, I have to reverse for give this peering name reverse. Let us take it from here itself. Say core to this particular manufacturing. Just say allow forwarded traffic. So basically what it's saying is allow manufacturing VNet to access core service VNet. And this is the remote for core services VNet while you're adding peering. Similarly for reverse, that means for core service to manufacturing VNet, allow core service to access manufacturing is what I'm configuring. First was for remote, that means manufacturing to access core. Another is core to manufacturing. That is what you want to add. Okay, so this is what just the the peering you have to have for the VNets you have just configured. Okay, so you are fully synchronized. That means anything which sits here will have the connectivity. Okay, so if you see this particular, it is connected. Okay, so this is what we used. Now, how do we test this? Uh, as interest of time, I don't have anything here. What I will do is, because I have already have my one particular services VM running in my another lab. So what I will do is, I will just show you on the connectivity in that. So let me go to the that resource group. Okay, so here let me go to the network, or I would say monitoring. Ah, so here, what I will do is let me start the other VM as well, which is manufacturing VM. Then we should be able to connect that connectivity test for both of them. Let me do that shortly. Rather than running in, I would say virtual machine. Yeah. So let me start this. Let me go to the virtual machines itself rather than. Okay, so let me start this VM. Within no time, it should be up. I think. Meanwhile, what I will go until it starts, I will go to the network monitoring and management. So this gives you basically in connection troubleshoot, we are actually trying to look into the basically VMs are able to communicate over different VNets. So we have already configured the peering for that. So what I'm trying to do here is this is source, this is destination. I'm just and remember we had the different ports 3389 because I may have turned that off. So let me check if this works fine because this is just to test that our VNet peering is working fine. See, okay, so this is reachable. So basically, uh, any particular port which you have opened on the respective virtual machines, just try to connect to them from a respective VM so that they are able to connect. Reverse also should work. So that means if I'm selecting manufacturing here and core services here, so even that should work fine because we want to test the peering both sides. So even that should work. Okay. So this covers our VNet pairing. Okay. So sorry, I could not do every lab because this will take at least 4 to 5 hours to do all the labs across. But at least you are getting the concept right, is what I want here. Okay. So now VNet pairing is done. DNS I have already shown you, so I have not have much on that. Now routes it's something which you should be aware of. That means if I want to force something that this particular VNet should go through this particular route only. So in that also you have the just go to the routes. Okay, there is something called route table. This is some sample route table I had for another lab. So what you want to do here is you have to go to the settings and create the routes. Now if you see the routes, it clearly gives you some name and what you want to do with. So I will give you the destination and I will give the next. Basically, what I'm trying to say here is this particular address should have the next hop. That means, I say suppose a particular, say suppose I want 10.40.0.0 should. Did I miss something? 10.40 dot. Yeah. So this is the complete address I want, and I want to have the next hop as my appliance or which firewall. I can give it to anything, but I think a virtual appliance is normally you have some firewall. Give the firewall IP here. So suppose that firewall IP address is say something in range of your. So give this IP address and click add. So this will force complete network range to go out only using this particular hop. So that is what the route is meant here. They are the one which forces your a virtual network being used by your VMs to follow the table and hit any of the appliances so that to know whether this is allowed or not. And this provides a security in place so that nothing goes out without your permission. Okay, so Azure routes will help you to actually control what's going out. Similarly is for the other destinations as well. It's for you to actually going over VNet or a virtual gateway for your VPNs. This is very helpful so that VPN knows where it has to come through and where it has to go out. So the example is also given. Router and on-prem, you normally go with virtual network, which I'm talking. Next hop will be VNet gateway. But for us internally, whichever are there something going, I'm going out from my internal Azure, I should follow some firewall devices given. Similarly, is something for internet. Okay. So with this, I think we come to the VNet gateway and express route gateway. Now, this is mainly used for VPN connection. The way I said, you should have the next hop as a VNet gateway. This comes into picture if you are want to connect an on-premise network to an Azure. So there should be some way of or some in point-to-point connectivity. So VNet gateways help us do that over the public network. That means I have an on-premise network, I have my Azure network. For them, the way you set the VNet pairing inside, but VNet pairing is a whole lot inside your Azure network, but here you are doing over the internet from your on-premise network to Azure network. Okay, so this is how the VPN gateway works. As this is an over internet, so we have the VPN configured. Rest all remains same. As I said, these are advanced services, so I'm not stressing much. Even your labs does not covers that. So I think as part of the basics, I think you should be good for exam. You just know what this particular service does and how you configure that. Okay, so last one is express route gateway for connectivity and this particular section. An express route and express route gateway is nothing but you have exactly the same thing, but only thing is now you are not going over internet. You have a connectivity provider. Again, on-premise and Azure is what the end goal is from an on-premise to an Azure or vice versa. But what I want is I want to have my own network. So I have a connective provider in between, which goes through a respective his own circuit, which gives me connectivity to something in Azure. So express route is nothing but without going over public internet, I'm providing my lease line connection from my on-premise or my office to an Azure. Okay. Again, here also the points to remember is you are purely running a dedicated circuit. So advantages will be high reliability, high performance, security, and obviously the connectivity or bandwidth remains good because you are on lease line or band, or I would say a broadband connection. Okay. So this covers our the second most topic or section where I think we covered more on the connectivity or intersite connectivity, which is on VNet pairing. So this lab also I think is straightforward. Just create those VMs. Sorry, I could not create on this lab, but I think I have shown you how the connectivity works and how the pairing is shown. Okay. So VNet pairing is done. Now, last topic is on load balancers and application gateway. So let me come to that particular topic. Okay, so now this is the last topic. So basically, Azure load balancer. Okay, here instead of hitting the respective VMs, like we connected your VMs, what we want is for a user, it connects to a load balancer and let load balancer decide to distribute the traffic to respective VMs. Okay, now this is very useful for me, like it distributes the load equally. So if you see the how it works as well, incoming traffic hits the load balancer and it check health probe basically checks that all the endpoint machines or all the backend pools are running fine, and then I actually distribute the traffic and provide the actual response. Okay, so this is how the load balancer works. The other is an application gateway. The difference is this is more to an IP and VM load balancing, but this is more of a layer 7 load balancing. Now layer 7, what do have? I have a different web servers at the back end, and again this is my front end service which is being hit from an outside world. Okay, so in short, what I have is I have the one at the network level, distributing at the IP level. Another is having the at application gateway, which is a layer 7 one gateway, which distributes the traffic to the different web servers. Okay. Now, if this is network, this is a layer 7. Another load balancing is a traffic manager, which is a DNS level. Now, where do I find the traffic manager, or how do I use that? What is the use of it? Basically, there are different things, like from if you are in different geography and you want to have a connection near to your geography, in that case this is very useful. Based on the network packets latency, it routes you to the your nearest region. So if you see this how it works, a user requests a specific website. Based on where you are, traffic manager decides your region to provide you a respective service. So from the DNS response, user connected to the endpoint which is near to that particular. Now there are also different ways. Sometimes you want a respective user or user group to connect to a nearby site. In case of any disaster, you want them to connect wherever they can connect, irrespective of geography. In that case, I would say a weighted distribution. Similarly, if you are a high priority user, I can set a priority so that you always connected to a instance which is faster. So there are different routing methods within this traffic manager, which provides me an opportunity to connect from an outside world to an instance which is near to me, which is best according to performance. Similarly, I also have the priorities being taken care. So remember, while you are looking at the slide, there are a lot of content, but I think you should read a basic what this is. Basically, a DNS based traffic load balancer, how it works is what you should look at to understand the basics of it. Okay. And front door is what something you have, like whatever you have seen on the hardware level application gateway traffic manager. Front door is something which can basically gives you whole lot of punch in one particular component. So here it is fully managed as layer 7. Only thing, only difference is the load balance, the basic load balancer which you have seen, which is at the virtual machine level. It will not be going at virtual machine. It will be providing an application gateway functionality. It will be providing a traffic manager functionality. So if you combine these two as well, traffic manager and application gateway, or Azure front door can do a lot more than that. So if you see the global IP, SSL, WAF, all these things can be performed by this front door. So if you will read out to this, the Azure front door is fully managed global application delivery service that provides an high availability performance and acceleration. And so for this, basically you come over HTTPS basically because it's a layer 7, and then routing rules and everything can be configured based on whether you want to have a use an API or respective website or something of that sort. You can hit any particular virtual machine app service or any of the I would say PaaS services. And again, the routing methods remains the same what we have been. Only thing is these methods depend on how we want to configure our networking. Or I want to say whether based on the priority, based on the weights, that means I want to equally distribute them. I want to distribute them based on who is performing good. That means latency is less. I want to give them the service based on the geography. And so Azure front door is also, in short, if I want to give you both traffic manager and the application gateway, it can perform both the functions in one particular component. Okay. Remember layer 7, and in basic load balancer, where you have to use them is for mainly IP based filtering or IP based load balancing. Okay. That is what our, if I close this out, the, let me close this tab so that we come to the last lab. So in network traffic management lab, what you will do is you have a template to create an infrastructure. I will show you this template, and then you basically create a load balancer. You also create an application gateway. Okay. And in interest of time, I have already this also available and ready with me. So I will show you the template, and then you can deploy this template on your own. And after deployment, I think you should be able to configure load balancer as one application gateway, the way it shows you. So without wasting much time, let's go through what this lab is all about. So in this lab, basically, we are going to build a custom template which actually does this networking part for us. So at backend, the template creates these VMs and make us available ready, so that while we create a load balancer, we can see that our requests are being passed on to these particular VMs. Okay. And so let me come back directly to creating load balancer. So basically these all it will ask you on the resource group and standard. So you have to give names up. Obviously this will be pre-populated. Just select the resource group, create a load balancer. Okay, make sure you have the public because we are actually doing the public load balancer. So you will have to have a front end IP, which will be the way we hit the load balancer. It has to have some IP, then it distributes to different virtual machines. In our case, is what you will do. Okay, and then at the back end, you need to make sure that you want to load balance two VMs. So you have to give those VM0 and VM1 as the backend, and then determine that load is getting distributed with the help of. So in step-by-step instruction, they have given you load balancing rules. So here till here you are front end, you created load balancer, you have a front end IP, you have backend pool. Now they are giving you a load balancing rule because obviously it has to work on some ports. So that is what these ports are shown to you. Okay. And finally, while you browse them, particular you should get hello from a respective VM0 or VM1. Okay, from the front end IP. So let me show you in my, let me go to Azure and show you that. First of all, I will show you the load balancer which I already created. First of all, I will show you the template, and then I will show you the load balancer and the application gateway, both of them. But meanwhile, let me first of all start the machines. So let me start these machines. VM0, VM1, VM2 as well. Let me start them. Start. Okay, so meanwhile, let me until it starts. I think we will be able to see the refresh that machines are, yeah, machines are running. So I will show you the template. Okay, so again, I have to go to the custom resource, custom template. Okay, deploy a custom template. Now in this template, I want to have a build my own template. Let me copy and paste. And remember, in this lab, they have also given you instruction where to get the template. So if you go to this particular, let me come to the top. Yeah. So if you go to the GitHub website for this, Just go to the lab 6. In files, you will get this parameter as well as the template JSON file. Okay, so I already have that with me. So what I'm trying to do here is I will give you or show you this particular template. Okay, so I'm just coming to the Azure. So this particular template has everything from the I've just copied, and a few things I've just changed is the VM queue size. I have whatever is available in East US. I've just changed this, and then rest I have just gone through and checked that wherever the VM size was there and respective address prefix, which that means the way we did in our first lab, make sure that address whatever you are giving is unique. But I think if you are going for first time and you don't have the that overlapping, I think just follow this lab properly, so that you should be able to create right away. Okay, so this is the template I have. Few things, as I said, this basically does nothing but create your virtual machines, networks, subnets available to you. See, this virtual machine is creating. Also remember that the 2019 is not available, so go for 2025 data center G2, or anything you want. But I think near to 2025 should be great because they are the latest one. So virtual machines will be created. Also, as we want to test the application gateway as well as the virtual machines, so it will also install some kind of PowerShell command. It will execute the PowerShell command on these virtual machines so that it gives you that you are running hello world from so and so computer. Okay, so I can show you this. Like, see, this is what you have to go to the template, and while you save this, while you click on save, it gives you this kind of a template to deploy. Just select the resource group and then respective. Also make sure you give the admin password for your virtual machines. Okay, so going back, I think our machines should be ready. So what I will do is I will just go to home, and I would show you the my labs where I have the load balancer already running. So what I will do is once my load balancer is running, okay, so when I get my load balancer is running, I should be having some IP, front end IP. So I will just copy this IP, open this and have this IP. Okay, so I'm getting this response from VM1 as of now. But if you keep on doing this, I think after some time, after timeout 4 or 5 minutes, you will get also VM0 as well. So this is how the load balancing works. Now, the other part which we have to see is this after load balancing is the application gateway. As I have explained you, this is more of a layer 7 related load balancing. So for this also they have given you instructions how you create after this load balancing. You have to create the application gateway. Okay. So here also I think they have the two VMs to be created and the network to be created. So just follow this particular instructions virtual network, and then subnet along with the starting address they have given. You're doing for first time, so should not be a problem. Just make sure you follow these instructions properly. You will get exactly the same thing. You will have a front end IP. The only difference here will be now you will be actually browsing on path base. That means what they have tried to do here is if I'm going for an image, it should go to the server one on NIC one. If I'm going to the video related content, then I should go to the server 2 for an application gateway. So that is how they have created these rules, path-based rules for images. So again, this in interest of time, what I'm doing is I will show you directly what I have configured before, but you can follow your labs. Let me show you the application gateway front end IP. Okay. So before that, I want to also see that all virtual machines are running. Yeah, all are running. So they are basically targeting one and two, right? So I just want to make sure that I'm having the machines running fine. Then application gateway should be able to provide me whether I'm hitting which machine. So if I go to this application gateway and pull out the front end IP, so if I give just this, it will hit any of those VM1 and 2. But if I go to say image content, which is path base, it okay. So it will be coming from VM1. Similarly, if I go for video, okay, it's it VM2. So image is on VM1, video content is on VM2. So that's all you have to do in this particular lab. And finally, you have to delete all the resource group. So coming back, I think I've explained you. I have to be a bit fast, sorry, because there are a lot of content to be covered. But then I think as this lab is too vast, it is difficult to cover based on the time we limit we have. But in short, I am just recapping what we did. So we gone through core networking fundamentals. We have seen the network connection topology so that you understand the basics. And then we started with the security, connectivity, load balancing, and finally labs. So coming to the after our fundamentals, from here onwards, I think you should be paying attention virtual network onwards. This is how you will be tested on exam. So you should be aware of each and every component and what is the functionality and how you actually there are no labs, but I think if you do it, it will be helpful for your production work which you will be doing on your companies. Okay, so wrapping up, there are the sections for security, which is related to service endpoints, your firewalls, and the application security groups. Then there's a section for connectivity, is where you are here for the Bastion, PNet pairing, DNS, and routing, along with VPN and Express Gateway. Finally, is your load balancing. So there are three sections basically you have to cover from an exam perspective: load balancing, application gateway, traffic manager, and front door. The labs covers the now this is a sixth lab. It gives you pretty much everything we need from exam per se. So again, that's all we have for this particular section. Thanks.